This is video number 4 for sections 8.3 and 8.4, Simplifying Complex Fractions Method 1. So now that we have kind of a basic idea of the process, let's look at an example where there are actual rational expressions involved here. Once again, this guy is called a complex fraction, which just means one big fraction that has little fractions in it. This is a big mess. Our job is simply to clean it up, to find some way to rewrite it so that it looks like a simpler fraction. Method 1, I've summarized for you over here. Here are the steps. You create one little fraction up top, you create one little fraction on the bottom, and then you divide, just as we did in the previous video. Now, I will tell you that in my opinion, method 1 is really only worth doing if the first two steps have already been done for you and you can just skip ahead to step 3. If that's not the case, method 1 really can take an awful lot of work, and I think method 2 would be superior. In this problem, I'm going to go ahead though and use method 1 because someone has already created just a single little fraction up here on the top and a single little fraction down here on the bottom. I can skip right ahead to step 3. Remember, this big fraction bar just means divide. So I can rewrite the problem instantly as that top fraction divided by the bottom fraction. And as soon as I do that, I'm now working with the kind of problem that we did earlier in Chapter 8, where we learned how to multiply and divide rational expressions. Let's see, division is something we don't do, so the very first thing I would need to do is convert this to a multiplication problem by flipping over the second fraction. Now what? Well, when I multiply fractions, I always look for an opportunity to cross-cancel common factors, but I cannot do that until I'm looking at the factors, which means I need to factor everybody. I have 4 factoring problems here to do. The good news is most of them are already done. X plus 3, there's no GCF, nothing can happen to it. It's already factored. I'll put the parentheses to remind myself that I did that already. X squared, that's already factored. That's just x times x. Easy. 4x, that's already factored. That's just 4 times x. The only one that I can actually do something with is this one here at the bottom. There is no GCF, but it is a difference of squares, which means it's going to factor a plus b and a minus b. Once all of my 4 pieces are factored, now I can look for common factors anywhere, top to bottom. And let's see, what do I have? Of course, I can see I have an x plus 3 here, and as well as one on the bottom. And then I have this single x. Remember, this is x times x, so this single x would get rid of one of those x's at the bottom. And I think that's all I've got. All that's left is then to multiply across. On the top, the only thing I have left is a 4. On the bottom, I have a single x times an x minus 3. Remember, we actually prefer to keep this in factored form. I could multiply it out, but we prefer to keep it in this form so that it's obvious to anyone looking at it that the answer is already reduced. We have taken this complex fraction and we have simplified it into just a simple fraction with one numerator and one denominator. Method 1 is pretty simple, but again, I think it's only worth doing if you can skip ahead to this step 3, which means you're starting with a little fraction divided by a little fraction. In our next video, we'll talk about method 2, which I think is the better way to go if you don't have this simple situation.